Hello, Stefano.
Hello, Alexis. How you doing?
I'm good. I'm good. How are you?
Fine, fine.
So today I thought I would walk through a dialogue that I shared a couple months ago, which shows how to use SolveIt in connection with Emacs, which is a text editor that I use. I know that you're not a super
I know you are an
I
Emacs
don't know how
guy.
familiar you are with Emacs, so you can be the person who asks the questions that everyone is clamoring to know about
You
Emacs.
tried a couple times to bring me into Emacs, and I tried a bit, but it's kind of hard at the very
That's not true.
beginning.
I never try to bring people in. I feel like knowing and making use of Emacs is like a privilege, you know, it's like an inherited privilege and you know, people are called to it and then if they're called to it then they'll do it otherwise, but it's not something to
Yeah, it's something
yeah.
you need to learn when you're a kid, like an instrumental, like
It is
anything.
a little well it is so I've been using Emacs for over 20 years, I guess, maybe almost 30. I don't know. When I went to college, I didn't have enough money to buy a computer, so I just had to use the one that was like in the computer lab, and not, but they didn't actually have a computer lab. There was like a little room that was like down the stairs from where my dorm was in the college, and in that room there was like a computer there, and I realized you could like, you know, run this thing Emacs on it, and I just do started to use that because it was already there for text editing. And then I kept going deeper into it from time to time. For many years, I didn't have any particular associations with it, but it was fascinating because if you open the help menu, it was like a text adventure video game. It was this like vast world of references to all this like 70s, 80s like Unix stuff I knew nothing about. I was kind of lost in it, but after spending a lot of time working with it, I'm now quite comfortable with it. And uh, Jeremy has talked a lot in the class, or a few times, about Lisp, the
Yeah,
Lisp programming language, and how Python has some of the features that were first introduced in Lisp and in Smalltalk. In particular, Jeremy's talked about the dynamism of Python, how you can like define things and then use them, and it's all interactive. You don't like make a file and come to it later. You can like do things right there. Um, and the Emacs program, among other things, it's a text editor, but it's not mainly a text editor. Emacs is more like Python than it's like a text editor. Um, because in the same way, Emacs is built out of Lisp, and it's a Lisp interpreter in the same way when you run Python 3, you're running a Python interpreter. So there's actually a lot of connections. So what I want to do here is I just want to show, first of all, a setup that you can use if you're curious to run Emacs in the SolveIt virtual machine. I'll show that first.
interesting.
And then I'll show how to connect SolveIt to Emacs so that you can like use AI tools in SolveIt to inspect what's happening in Emacs when it's running, or use uh, commands in SolveIt to run Lisp code that will run in Emacs. And then maybe I'll show a little bit to give a sense of like
Okay, okay.
why you'd
Let's
want to
take a
do
look at a
this.
couple of
Okay.
use cases. So,
All right. Um, So really it's kind of a taste of like how to extend SolveIt in maybe improbable ways, but then also a kind of taste of what Emacs and Lisp is and how you can think of Python and SolveIt as a kind of extension or reinterpretation of some of those ideas. All
okay.
right, so this is a notebook that I shared before. Is this visible or is it too
Yeah,
small?
yeah.
Okay, so this is like the right
Yeah, it's
size.
kind of smallish, maybe for the
Oh,
audience that'll have, yeah, maybe a little more
all
compression.
right, I will pump that up.
Cool.
How's that better? Okay, cool. So I'm going to not run all of this, but kind of walk through it, but this is a share that's available. Um, so the first part of it is installing Emacs inside the Solvit virtual machine. Like when you're dealing with the Solvit notebook, it's running in an environment where you have access to a virtual machine underneath. And if you click this terminal button up here, you get access to a terminal. You can see it right here. So, you know,
There
there's
we
my
go.
terminal. And I'm looking at this notebook right here, Emacs with a capital E. And here in the terminal, you can see there's the file, emacs.ipynb. That's the
Okay, so
same
you are in the
notebook that we're
same
working on.
folder as the dialog in this moment.
Yeah, yeah. So there's
Okay.
the dialog, emacs.ipynb, and here it is. Now I'm looking at the notebook. And first thing you want to do is install Emacs. and I've uh, figured out for you guys and for myself a shell script that can be used to install Emacs on a system even when you don't have administrator access to the system. This
Ooh.
makes use of a packaged bundle where all of Emacs is put into one giant file, and then it sets up things in the file system. So it runs perfectly fine as if you've installed it as an administrator. So if you were doing this on your own, you'd want to just execute these dialog messages, which would install Emacs, and then Emacs is ready to go. In
Okay,
fact,
it's installing in local bin Emacs. Okay, so it's actually
yeah,
changing your instance, adding these things. So maybe you want
yeah.
to try this dialog into a fresh new instance. If you don't want anything to change, that's going to be persistent.
Yeah, and then
But
once
yeah,
it works, you should see Emacs already installed. If you want to see where it is, you can see. I think I've dumped it in .local.bin. So if we go here and look at .local.bin,
yep.
there's like a
There we
bunch of
go.
Emacs stuff. Um,
There's a bunch of Emacs. Yeah, client.
some of that stuff that I added. What you'd find if you just did it was a little less. All right, so now
Okay.
let's say we're done with the boring part. We've installed Emacs. Now the next step, oh, I always forget which one of these to do. Uh, there we go, is to start Emacs running in the background. Um, so you know the idea how when we're in a SolveIt notebook, Python
Yeah.
is running and I can define a function, right? So in the same way, we want to have Emacs running so we can define an eLisp function, define a function in Emacs or talk to Emacs. So
Okay.
in other words,
It's like starting the kernel
yeah,
where the dialogue is going to talk to. So it's the kernel doing the job, and now you have the Emacs running that's doing the job. So you say that this is not started, so you can make a PS in the machine, you're not going to see Emacs. But after running start Emacs, it's a PS.
yeah,
I'm going to
because
find that
it'll be
process.
a running
Okay.
process. So I'll do that right now. Let's see if it works. Start Emacs server. Oh, that defines it.
Okay.
Okay, now I'm gonna
Find
run it.
function.
All right, starting Emacs daemon. And I like your idea of how to test it. So let's right now look at our process
Pipe
tree
grab.
and search it for Emacs. And there you go, I think.
There we go.
There we go.
Okay.
Emacs daemon process number 399. So it's running. Okay. Now, what I'm going to now Emacs is a very small core of C code, and the rest of it's Lisp. And what I've got here is a function that you can use to evaluate the Lisp code in the same way that you evaluate Python code. So first, let's just build the function in a kind of simple way, and then we'll use a magic to make it easy to use from the notebook. So here I've defined
Okay.
a Python
Oh,
function.
you get into the magic now. I remember you said
Well,
once,
yeah, we
but
need a
I'm
little.
doing this very, very serious.
We all need a bit of magic in our lives, don't we? Yeah. So eval Lisp for value. So
Okay.
evaluates an Emacs Lisp expression and returns the resulting value. And what it's doing here is it actually is calling command called Emacs client,
Hmm.
which is the client that talks to the Emacs daemon that we're running, and it passes in dash E, which I think is short for dash dash evaluate.
Yeah.
And then here's the code that it runs. So let's see if this still works. No reason it should stop. So if I want to evaluate uh,
Okay. Oh,
one,
that's
two,
the
three.
RPN, the reverse Polish
Yeah,
notation,
so
right?
here we come to the most famous thing about Emacs or about Lisp, which is that it uses parentheses where some other languages use curly
Yeah.
braces, and that the operator is put first. So instead of saying 1 plus 2 plus 3, you say plus 1, 2, 3, uh, which is actually, the same order that we're using here in.
It's like writing some of those.
Well,
That's
it's actually exactly the same order as in Python. Notice we have
yeah.
eval Lisp for value and then a string. We don't have um, the string and then the function afterwards, right? We have the same order. It's just where you put the parentheses. It's not such a big deal, really. Um, Although it frightens some people. So here we're evaluating this, and this sum was computed in Emacs because we actually called this function and got the value out and put it here. Um, Here's a slightly more involved example. So I'm passing
Okay.
in a string with quotation marks to be evaluated. So this is just a string literal in Emacs
Okay. It's
Lisp.
it's 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 a literal. I got you.
Yeah, it's a
It's a,
literal.
yeah, yeah,
So a
yeah. I got you.
literal evaluates to a literal. Um, However, what we'd like to do is have it be um, have the value come back neatly. Let me see if I can show what I'm doing here. We don't just want to get values back. We also want to deal with expressions where it might print out something, and then we want to see
Okay.
the printout, right?
Oh, so you need
So
like to catch the console output and
right,
redirect. Ah, I got your
right.
point. Got your
So
point.
what I did here, and I'm not going to go into the details on this,
Can believe it.
is I wrote a chunk of Emacs Lisp with the help of AI, of course. I'm not so clever to do this in my spare time just for fun. Um, which takes the bit of code that you want to evaluate. So here's a little bit, here's a string that represents Emacs Lisp code, and then it wraps it in all this Lisp. And if you can see what's happening here, it's setting up a kind of capture environment. It's going to capture
Mm,
standard out. It's going to capture standard error. It's going to capture them into memory buffers, actually editing buffers.
yeah.
And here it's going to actually execute the code. I'm looking for it in here somewhere. Where is it? If we look around, we'll find code interpolated. Do, do, do,
Should be
do.
in the bottom line. Like I see maybe
Oh
that's
yeah, well
yeah, over
it's
there.
passed in
When you're
here.
running over there, so like you
Yeah.
define the
So
function
I've
with
so I've defined a
captured.
function. I've defined actually a macro called with captured eLisp input output. It takes a file that will be where it dumps standard out. It takes a file that'll be where it will dump standard error, and then it takes Emacs code to evaluate. And then here, look for the word body somewhere in here.
Yes, I see a missing parameter. We're like,
There it is, body. So
okay.
here is where it actually is like inserting the code that gets evaluated, captures the standard out, captures the standard error, and writes it to those files. And then I have Python code here that reads those files. So in this way, I take a small piece of Lisp code and evaluate it in a context where the return value, the standard out, and the standard error are all like captured. And now using this, we can do any kind of a Lisp evaluation we want. So here is, evaluating. Oh wait, I forgot to define this thing.
Yep.
It's not going to work if I don't define it. Um, so here, yeah, all right. So now I've evaluated this Lisp expression, which says do a print of hello world with a new line between hello and world. And you can see there's the output value, there's the printed
Okay.
output, and there's the standard error. All right. So now what have we done? We've now built like a thing in SolveIt that we can use to evaluate any Lisp expression using an instance of Emacs that's running on the virtual machine. But we want it to be more convenient. Instead of calling this function, we want it just to be do it in SolveIt. So I'm now going to create a magic. So a cell magic is a thing that lets you define effectively a new kind of input cell where the cell's contents are evaluated by your function. Um, so I've defined a cell magic, and now I have a cell magic that lets me just evaluate eLisp. So here I'm going to evaluate, 1
Hmm.
plus the product of 3 times 4.
Oh, by the
And
way, I really like your idea to breaking the problem down into smaller functions. So you define all the logic to do execution and grabbing into a separate function that you can test it. You just proven
yeah,
that it's working. And you can, if something's going to be wrong, you can debug only the important thing. And eventually you just wrap it into a magic. And so you're going to be sure that the magic is working because it's
yeah.
working because
So this is
what
the sort
magic
of
is doing is calling something that works.
very much so. This is the kind of incremental problem solving approach that
It,
SolveIt
it's
is
a
really
solve a
built
thing. Yeah.
to support. It's also the only way I can manage to muddle through this stuff. I get a basic thing working, and then I know it works, and then I can build another thing on top.
Exactly.
So just to show examples here, this is evaluating, function application. Here's the same thing we saw before, that a string is an atom. It's a
Yeah.
literal.
Can you
In
have some sort of like a logging in your Emacs that you see things happening there, or just transient buffers stuff that you're not gonna see?
well, every time we're evaluating this, we're not creating a new Emacs process. We're just
Yeah,
talking
yeah,
to an
yeah.
Emacs
You're
process that's there.
acting
So
on the same state.
So I think if I went to that Emacs instance and looked in a buffer called messages, I would see any messages that I displayed. So
Oh,
everything's in, or I could look at probably the evaluation history. Maybe we could have a look at that after, but
cool.
I'll work through these examples just to show it, and then I'll show like what's happening on the Emacs side. Um, but this is just, in Lisps, there's this notion that's a little different from a string called a keyword. Instead of none, you have nil. It's the same kind of stuff. But we could
Oh,
also,
there's one thing I want to point out because it's boils down to a discussion that I have with Alex, and it's, can you scroll up a little bit? The only kind of like sad thing is that when you define a cell magic,
Hmm.
you cannot change the kind of syntax highlight that the cell is
Oh, okay.
containing. So
Mm.
like I wanted to find a Lisp cell and I wanted to see the Lisp syntax highlight. And I have this discussion with Alex about that. I say, just maybe we can just hack when you execute the cell, you're gonna hack and inject a code mirror for Lisp. And so after you execute the cell, you
At least get after the
you
fact syntax
color the
highlighting. Yeah.
syntax in the right way. And so you can really have something that's
To be
really
honest,
useful.
I bet you could do this because we're using the Monaco editor. So if one
Yeah,
found a way to, in the browser, just hit the Monaco editor API and say, "Hey, I need you to syntax highlight this like it's Lisp,"
exactly. Do
I
not
think I
look
think
at
it
this
would
as a
work.
Python. Look at this as something different language.
Yeah. I mean, I
Yeah,
think that's
maybe
probably,
some homework for the next time.
yeah, we can save that for the next share. Let's keep moving. I don't want to go over time. So here I
Yeah.
have a more evolved, a more involved uh, hunk of Lisp. Let's evaluate that. Um, and
Oh.
did I
Oh, by the way, we're gonna cheat this time. We're gonna like speed up the time so we can like shrink it down the video.
yeah. Um, oh, okay. So what we've done here, if you look, it says with output to temp buffer. So this has done something, but it saved the value in an Emacs buffer. It didn't print it for us. So this is like a
Oh,
reminder
that was
again of
my
the virtual
question of
machine
before.
state. Yeah. So put it in fact in a buffer called star m star. That's like right there. I put that in as
Yeah,
a
I
literal.
want to see this die now. Like
Right.
no matter if you run out
Okay.
of time.
So the thing to emphasize now is that Solve is very extensible, and what we've just done is create effectively a bridge with another virtual machine. It happens not to be a Python virtual machine, it's the Emacs Lisp virtual machine. But we can use that for anything because now we can evaluate code in that other virtual machine. And so far, we're just using it to do an evaluation and get a result back, or do an evaluation and change the buffer there. But we could make it more general, right? Since we're doing this with Python functions and Solve it, we can now define AI tools that let us inspect that other environment. So in Emacs, just like in VS Code, you're editing files. In Emacs, you're editing buffers. So here, let's define some Python functions
Oh,
that
so you
now let
can
us like
kind of like a
script
call
the editor.
any editor function and see the result here. So
Yeah,
you go list an open file. Oh,
yeah.
uh-oh. It's
So
getting
if I
interesting now.
now click define a list buffers
Okay.
Python function, it's giving me the list of buffers in that
The
Emacs
M1.
instance.
Look at
And
that.
look, there's the mystery M1. And I'll
Yeah.
define another Python function, which again is just feeding in this
Okay,
Lisp code,
pretty
which
good.
lets me view a buffer, right? So this said, hey, with the current buffer that was specified as the argument, turn the buffer into a string. That's buffer substrate. No properties means get rid of like rich text highlighting, and get the whole buffer. So start from the minimum point in the buffer to the maximum point in the buffer. That's all that's doing. It's nothing scary. And now we can see what's in, say, the scratch buffer.
Okay.
So this text here is the contents that you see. If you start Emacs, it opens a buffer for you called Scratch and says, "Hey,
Mm.
here's where you can write stuff." And now we can see what's in the
Yeah,
star.
and thanks they tell you how to exit Emacs at the very beginning. So,
Yes, at least they give you that
I
hint.
know
Not
about
all that hint.
the VI jokes.
Yeah. And so here's actually the contents of the M buffer. I don't know if you can quite see it, but if you squint and
It's a
step back,
fractal.
yeah, it's the
It's a
Mandelbrot set.
manageable set.
Yeah, yeah. So so we computed the Mandelbrot set and saved it as text in
Oh, that's
in an
awesome.
Emacs buffer because
That's awesome.
what else?
You should write it with the color number so you can like more appreciate.
Yeah, no, that'd be the next step. Um, okay, so far so good, but those functions are also tools. So now we can talk to SolveIt and ask SolveIt to explore what's going on in the Emacs buffer. So here I'll rerun this, and the SolveIt AI is now using
Uh-huh.
those Python functions to
Okay.
explore the Lisp environment and telling me uh, what's there. So, if you want to think about what this is like let's say you were using like VS Code, this would be like talking to, um,
Okay. I'm gonna make a
Solve It
bold
or
statement
Claude
now.
Code or whatever, and saying, hey, tell me, what files I have open in VS Code. Tell me what's in this file.
I want to
Yeah.
make a bold statement. Like I wanted to prepare the recursive LLM paper analysis notebook that like both Marcus and Nate dive on.
Hmm.
And I'm actually realizing that instead of having the memory into a Python variable, you can have the memory into your Emacs. So having your context into your Emacs and having the recursive agent
Hmm.
using function of Emacs to manipulate the context that is written into an Emacs buffer.
Yeah.
That's an interesting thing. I
So it
need
it
to
gives
read
you
more the
another
paper and
it gives you
understand if
another
this makes
working
sense.
space. Yeah. I mean, like right here, you can do a lot
Exactly,
within
exactly,
a solvent note, but you might, be interested in having a full editor in some environments. So here's create buffer. So I'm creating another function here.
exactly.
And then if I list buffer, I guess I just saw the one I created. Well, no, I haven't created one yet. Okay, I'm creating a buffer here called test buff. Um, and now
Oh,
I guess, or no, this is showing me the contents of a test buff. Or actually, no, I created this function, then I never called it. So not a very good demo. So I should add a call to it right here. How about I do that? Where's the oh my gosh. Um yeah, so let's create an example of that like here. So let's say I now want to create a buffer in the Emacs. I'll call it the Stefano buffer, and the contents
okay.
will be uh hello Stefano.
Oh, call it context buffer. It's the same kind of name they use in the
Yeah.
LLM,
And
but
there we see like inside this Emacs there's Stefano.
now
So
we
so far
have new one.
I've been describing like, hey, there's this Emacs, this thing's happening. It may sound like a ghost, but let me just show what it looks like briefly. How far are we on time? Am I already past 15 minutes?
It's okay. It's okay. We're gonna like a
All
super
right,
shrink the
I'm not
time,
very good at
so
this.
we're gonna have a very
So
high pitch when we want to talk.
yeah, okay. So if I like go to the terminal now, um,
There we go.
I can run Emacs client directly. Um, let me see. Let's say I want to do Emacs client here. So this is now I'm in Emacs,
Yeah.
and if I do Control X, Control B, you can see those are the
Haha.
buffers that we were just working on, right? So
Oh, so you have multiple client insisting on the same Emacs server, of course, and
yeah, there's one Emacs
you
server, and you
will
could have
use. Yeah, yeah,
clients.
yeah. I got it. Sorry.
So this is one client into it. I could actually, I think, run a client on my Mac and have it connect to it. Solve it interacts
Gotcha.
with it from the Emacs client. Um, and like, there's the same buffer that we were just talking about.
Haha.
And I'm in the SolveIt VM now, but I have a complete like text editor environment. And again, Emacs is not just a text editor. If I did REPL, I think that's what it is. No, what is it? I'm so used to the uh, here. Let me actually show a different way. So I will kill the Emacs that I have going just to show what's going on
Okay.
here. So we created this daemon that's 399. Let me
399. Yep.
make sure it's dead. Okay, good.
Oh, still
That's
there. Oh, defunct. Defunct. Sorry.
all right. Yeah. And now what I'm going to do is this is the kind of plain vanilla Emacs that you just get out of the box, as it were. I'm going to switch the configuration underneath to use the same Emacs configuration that I use on my Mac.
Okay, so you move your dot
Yeah, so
Emacs.
I'm just switching the
Gotcha.
configuration setting. And now when if I run Emacs, um, it
Oh, yeah, that's a
it looks
different
a little
Emacs.
different, right? Because now I've got the stuff that I usually use every day.
Okay.
And it's like
And
set up with
that's
more
really the
colors.
thing that always envy from people using this historical editor that you
Hmm.
never need to relearn everything from scratch. Everything start is there, and even in this case, everything can run on a remote machine in the same way that it runs on your computer.
Yeah,
So just terminal
yeah.
stuff.
Well,
It's
this thing's been around, for quite a few decades, and I think it'll still be around when people have forgotten about VS Code and whatnot. I don't know if it'll be the best thing. It'll still be like what it is.
yeah.
But the thing I wanted to show is that it's mis it has a REPL in it. It's a mistake to think of it as
Oh, Elist.
just
Okay.
a text editor. Like this is exactly the same environment that we were just interacting with sort of remotely from Solvit, but um it's it's just like the Python REPL. It's like an
Okay.
editing environment, and you can like define functions and do things. It's also like Python in the sense that there's an entire package manager. Like if I display a list of packages, these are all packages that I can install if I want to. Uh, and
Okay.
I have a lot of them already sort of pre-installed. So if I say go and look for Jupyter, these are different. Okay,
Okay.
so here's a package called Jupyter that I've already installed. And what Jupyter lets you do is it lets you open Jupyter notebook files and ha have other types of interoperations with Jupyter format things. And since SolveIt uses the Jupyter notebook format, what I can do here in Emacs is I can go right to the IPyNB file, which represents the SolveIt notebook we're working on, and I can open it in Emacs. And instead of seeing the JSON, it's going to automatically dynamically convert it into another format for me because I've installed that package, which makes that easy. So here is the uh, SolveIt notebook we were
Yeah.
just looking at, the same file, but being seen now from this editor, the Emacs editor that's running in the SolveIt environment. So if I made a change here, um, I could say Emacs looks like a text editor, but this is an illusion. Uh, in fact, uh, you know, folks use it every day for editing and saving the file. This is a live test. I haven't done this before, and I think it should be saving it correctly in SolveIt format. And let's see if that made it through without corruption. It might not have, to be quite honest. Um, Emacs looks like okay. So now if I
Maybe
refresh,
refreshing the page
yeah. Um,
every day.
no, it's not changed here. Okay,
No,
so there's
it
some
was
detail to
a
figure
typo and
out.
I didn't see the typo here. So yeah.
Yeah. Okay. So there's some detail to figure out there, but at least we have like viewing of the notebook correctly. Now I'm really curious what's going on with that one, but I'll figure it out later. Um, so anyway, that's just like a
You
little
can just
taste
open
of
like
like,
that and it's gonna interpret and you have the plugin that lets you understand it properly. I gotcha.
yeah.
Hmm.
I
I
suspect
was
what's
kind
going
of
on.
interested that
Hmm.
it's injecting that maybe Solvit is hiding some stuff like line 39, the export is hidden by Solvit, or I don't remember.
No, I don't know. I think so. It's clearly reading the IPyNB file, but it didn't save it properly.
Mm.
I don't know if that's because Solvit clobbers it or something else.
Yeah, yeah,
I
maybe
have
there's a
I
race
haven't
condition
to
between
be
the
honest,
two.
I
I don't
haven't
know.
looked at it that much. It's just
Yeah.
when you're in a shell environment, you'd like to have your editor, and this is the editor I use, so I figured out how to get it running here. But Jeremy's talked so much about the dynamicism of Lisp that I thought it would be interesting for people to see what that means, and that Emacs is just like Python. It's a dynamic programmable environment. Um, uh, every kind of function that we're using here, uh, like here, Jupyter run REPL. Uh, if you want to, you can just go and see the code for it, right? All the code
Mm.
is right there. And if you modify the code and evaluate it, it's running right away. You don't need to recompile it. So it's like solve it that way.
Yeah.
And the function definitions are right there. You can inspect them. You can redefine them. It's a live programming environment, right in front of you. It's not a kind of frozen thing that was shipped to you. You don't need to go learn C++. And then like recompile and then like, get the provisioning cert from Apple. It's from a different era when things were a little more hackable. Okay,
Okay.
don't tell me how long that was. I don't want to know.
I'm gonna tell you, you're gonna have a
Okay.
very high pitch when I shrink down the.
Okay.
No, no, that's gonna happen. It's gonna be impossible to follow by. So yeah, that was a joke.
All right. Any questions?
Alexis,
Any
that was
thoughts?
very, very interesting, and yeah, looking forward like to do next stuff with this.
All right. Cool. Well,
Okay.
it's good to see you again.
Thank you so much. Bye. Bye.
Bye
Bye.
bye.